So last time we have derived the expressions for normal and the shear stresses. So today we will continue with those expressions, and along with that we will also solve one numerical related to this. So let's start with our today's lecture. Ji, so let's start with the lecture. I'm going to start the recording. जी, Bismillahirrahmanirrahim. Last time we had derived these, what you say, derivations. Sigma x dash is equal to sigma x cos square theta plus sigma y sin square theta plus 2 tau xy sin theta cos theta. Then we derived this expression, sigma y dash is equal to sigma x sin square theta plus sigma y cos square theta minus 2 tau xy sin theta cos theta. The third expression which we had derived, that was tau x dash y dash is equal to minus sigma x plus sigma y times sin theta cos theta plus tau xy cos square theta minus sin square theta. Fine. So these three expressions which are written in the black, these three expressions we have derived last time. Now what we want to do, we want to simplify these expressions by putting the identities in them. So how we are going to do? So let's start with the first expression, that is sigma x dash is equal to sigma x cos square theta. So cos square theta, we can replace cos square theta with an identity, that is 1 plus cos 2 theta over 2 plus sigma y sin square theta. We are going to replace this with an identity, that is 1 minus cos 2 theta over 2 plus tau xy 2 sin theta cos theta. We can replace it with an identity sin 2 theta. Okay? So our simplifying equation can become sigma x dash is equal to sigma x 1 plus cos 2 theta over 2 plus sigma y 1 minus cos 2 theta over 2 plus tau xy sin 2 theta. And when we simplify this, so we are going to open up the brackets. So it will become sigma x dash is equal to sigma x over 2 plus sigma x over 2 cos 2 theta. Is this point clear? Sigma x over 2 plus sigma x over 2 cos 2 theta plus sigma y over 2 plus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. ठीक है जी? Is this point clear?
Yes, sir.
So sigma x dash, now we will just rearrange the dash is plus sigma. This expression will become sigma x plus sigma y over 2 cos 2 theta minus 1 cos 2 theta. So this will become sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta plus tau xy sin 2 theta. Is this clear? And calculate the transformed normal stresses about x dash axis by just putting the value of the stress sigma x, sigma y and theta. ठीक है जी. So you will just put the values of normal stress sigma x, sigma y, shear stress tau xy, and the value theta, and you will get your transformed normal stresses dash. Everyone clear with this? If you have any question about this, please ask me now. The second expression which we have derived or developed last time, that was sigma square theta plus sigma y cos square theta minus 2 tau sin theta cos theta. ठीक है जी. So now sigma y dash is equal to sigma x sin square theta. We are going to replace sin square theta with an identity, that is 1 minus cos theta over 2 plus sigma y this sigma y cos square theta. We are going to replace it with identity, that is 1 plus cos 2 theta over 2 minus is this y 2 sin theta cos theta is basically identity sin 2 theta. So 2 tau xy sin theta cos theta, we are going to replace 2 sin theta cos theta with sin 2 theta. So afterwards we will just rearrange the elements. So we will rearrange the elements. Sigma y dash is equal to sigma x over 2 minus sigma 2 theta plus sigma y over 2 plus simplification, my equation will become as sigma y dash is equal to sigma x minus tau xy sin 2 theta. ठीक है जी. So this is now the second expression, that you can calculate the normal stresses about the transformed y dash axis by just putting the values of sigma x normal stress, sigma y shear stress tau xy and the theta. If you see the difference of the signs, is this clear? Okay. Next equation which we had derived last time, that was tau x dash y dash. Tau x dash y dash is equal to minus sigma x plus sigma y sin theta cos theta plus tau xy cos square theta minus sin square theta. So tau x dash y dash is equal to minus sigma x plus sigma y. You replace sin theta cos theta with an identity, that is sin 2 theta. ठीक है जी. Because 2 sin theta cos theta is sin 2 theta, so this will become half, because this is just sin theta cos theta. It is not 2 sin theta cos theta. So identity will be sin 2 theta over 2, sin 2 theta over 2 plus tau xy cos square theta minus sin square theta. Cos square theta minus sin square theta is equal to basically cos 2 theta. So this equation will become plus tau xy cos 2 theta plus tau xy cos 2 theta. So this equation will become tau x dash y dash. Tau x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta. ठीक है जी. Plus tau xy cos 2 theta. So it means I can calculate the transform shear stress. I can calculate the transform shear stress by using normal stresses and the shear stresses along with the theta value. So these three equations, this equation sigma x dash, equation 1, sigma y dash, equation 2, top x dash y dash, equation 3. These three equations are my main equations for the calculation of the transform normal and the shear stresses. For the calculation of the transform normal and the shear stresses. If you have any question about this, please ask me now. If no question, then we are going to do the numerical. If no question, then I am going to start the numerical. Okay, ji. Everyone can see the question.
Yes, sir.
Everyone can see the question. It's example 9.2 of the book. It is example 9.2 of the book. The question statement is the state of the plane stress at a point is represented by the element shown in the figure 9.7. Okay, so if you can see this, there is a normal stress sigma y. Normal stress sigma y, that is 50 megapascals. Normal stress sigma y 50 megapascals. Then you have normal stress sigma x. Normal stress sigma x, that is minus 80 megapascals. Why negative 80? Because this arrow is pointing towards the negative x-axis. Is pointing towards the negative x-axis. So it will be minus 80 megapascals. Now this is shear stress as a designation. Now over here, point is positive. And if the vertical and the shear stress is pointing downwards, if the vertical arrow of the shear stress is pointing downwards, then that will be negative. So the shear stress we have is minus 25 megapascal. So I repeat, the state of plane stress at a point is represented by the element shown in the figure. So we have to determine. So now from this element we know that sigma x is minus 80 megapascals, sigma y is 50 megapascals, tau xy is minus 25 megapascals. Okay? Now we have to determine the state of the stress at the point on another element which is oriented 30 degrees clockwise from the position shown. So what we have to calculate, this is your regular axis, x-axis. Now your element is oriented at an angle theta clockwise. Okay, now at an angle theta clockwise, I have to calculate the plane stress, the state of the plane stress at this point. Okay, so I have to calculate sigma x dash, sigma y dash, and top x dash y dash. Okay, for theta 30 degrees clockwise. Just for your understanding, as earlier we have taken clockwise as negative and counterclockwise as positive. Clockwise as negative and counterclockwise as positive. So clockwise is negative. So it is the state of the stress we have to calculate at the point which is oriented 30 degrees clockwise. So 30 degrees clockwise means minus 30 degrees. Is the question statement clear? Question statement clear? Question statement is clear?
Yes, sir.
Okay. Now let's start with the solution. So can you see these figures? Can you see this?
Yes.
Actually, can you see this, guys?
Yes, sir.
नहीं आ रही है फिगर? Can you see this now?
Yes, sir.
Okay. Now the question statement, I have drawn the figure that sigma x is minus 80, sigma y is 50, tau xy is minus 25 theta is minus 30 degrees. This black regular x, this black color line, ठीक है जी, this black color line is over regular x and y axis. ठीक है जी. Now we have to draw over rotated axis or transformed axis at an angle 30 degrees clockwise. So I have drawn this red line, red dotted line. This represents my x dash axis, which is oriented at an angle 30 degrees with reference to the horizontal, with reference to the 30 degrees to the horizontal. So this is my x dash axis, which is rotated at an angle 30 degrees clockwise with reference to x axis. Then we have this y dash axis, ठीक है जी, which is rotated at an angle 30 degrees clockwise with reference to y axis. ठीक है जी. So these are my rotated axes. This red color is my rotated x dash axis and green color is my rotated y dash axis. Green color is my rotated y dash axis. Is this question statement clear?
Yes, sir.
Okay. Now we are going to calculate the transformed normal stresses and transformed shear stresses. So sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. So can you please put the values of sigma x as minus 80, sigma y as 50 and tau xy as minus 25 megapascals. ठीक है जी. And theta is minus 30. So can you please calculate sigma x dash? जी. Guys, can you please calculate the value?
Sir, minus 25.849.
Okay. Minus 20. We will 2 decimal places are sufficient. Okay, 2 decimal places. So sigma x dash is equal to minus 25.85 megapascals. So sigma x dash is equal to minus 25.85 megapascals. ठीक है जी, sigma x dash is equal to minus 25.85 megapascals. Okay. Next is we need to calculate the transform normal stresses sigma y dash. Sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sine 2 theta. So can you please calculate sigma x is minus 80, the same as above. Sigma y is 50 megapascals. Tau xy shear stress is minus 25 megapascals. So sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sine 2 theta. So please calculate sigma y dash. Please calculate sigma y dash. Please calculate sigma y dash. So please calculate sigma y dash.
Same it's same.
4.15 megapascals. 4.15 megapascals. ये रेड वाला आएगा. 4 minus 4.15 megapascals. डन हो गया. Now next is we have to calculate the shear stress. We have to calculate the shear stress. So transform the shear stress. Tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So please put the value of sigma x as minus 80, sigma y as 50, theta as minus 30, and shear stress as minus 25, and let me know the answer. So what's the value of transform shear stress? Tau x dash y dash.
minus 68.79 sir megapascal.
Minus 68.79 megapascals. Now this means that my transform normal stress about x dash axis is minus 25.85 megapascals. My transform normal stress about y dash axis is minus 4.15 megapascals. Okay, so and shear stress, transform shear stress, we have got as minus 68.79 megapascals. Now what we are going to do, we are going to repeat the same question. With the same data, the only difference over here is that instead of having my x dash axis rotated at an angle 30 degrees clockwise, it is now rotated 60 degrees counterclockwise. 60 degrees counterclockwise. So you can call this as part B of the question. Part B of the question is that over element is rotating at an angle 60 degrees counterclockwise. 60 degrees counterclock 60 degrees counterclockwise. ठीक है जी, 60 degrees counterclockwise. Fine. 60 degrees counterclockwise. So now your theta will be plus 60 degrees. So now the same question, sigma x minus 80, x minus 25 with theta 60 degrees positive, with theta 60 degrees positive. ठीक है जी. So can we calculate sigma x dash? Can we calculate sigma x dash, sigma y dash, and tau x dash y dash? G, can you please calculate sigma x dash? Now, the thing to be noted here that instead of using theta minus 30, we will use theta 60 degrees, and it is positive. Theta will be positive 60 degrees. Theta will be positive 60 degrees.
Yes, sir. The answer is minus 4.15 megapascal.
So sigma x dash we are getting as minus 4.15 megapascals. ऐसे ही है.
Yes, sir.
Okay, sigma x dash is equal to minus 4.15 megapascal. So normal stress about this x dash axis is minus 4.15 megapascal. Now next is I have to calculate sigma y dash. Y dash. So sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sin 2 theta.
Sir, minus 25.85 megapascal.
Minus 25.85 megapascal. So normal stress about y dash axis is minus 25.85 megapascals. And please calculate the transform shear stress tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So please calculate the transform shear stress tau x dash y dash.
No one.
जी
68.79 megapascal, sir.
68.79 megapascal, and this time the sign is positive. 68.79 megapascal. Now let me show that why I have asked you to calculate the transform normal stresses and shear stresses at theta 60 degrees. एक सेकंड ठहरिएगा. ओके, जस्ट वन सेकेंड, मैं इसे कोशिश कर रहा हूँ कि ये दोनों को देना। ओके, नाउ guys, I think I'm good. Okay, the point which I want to emphasize here, that over normal stresses, transform normal stresses and the shear stresses, sigma x dash, sigma y dash, and tau x dash y dash, they are like on the same plane, their values are same. I repeat, their values on the same planes, their values are same. Now see this. In this first figure, this is your x dash axis, which is 30 degrees clockwise. Now in this figure, this y dash axis is actually 30 degrees from x axis. Okay, this y dash is exactly at the same orientation as this x dash axis. So when you calculated sigma x dash, which was minus 25.85 megapascals over this axis, ठीक है जी, minus 25.85 megapascals. Now when you calculated the transform normal stresses sigma y dash, this one, this was again minus 25.85 megapascals. So it means sigma x dash, this one, and sigma y dash, they are same, they are same. ठीक है जी. Now if you see this y dash axis and this x dash axis, they are oriented at exactly the same angle. So this y dash axis sigma y dash is minus 4.15 megapascals. This is minus 4.15 megapascals, and in this case sigma x dash is equal to minus 4.15 megapascals. So it means that the normal stresses, their magnitude over the plane will remain the same. Only their designation will change, whether it will be sigma x dash or sigma y dash, but their magnitude over the plane will remain same. Is this point clear, guys? Is this point clear, which I am trying to emphasize here, that over the same plane like y dash axis and x dash axis, the normal stresses, their magnitudes are same. Their magnitudes are normal stresses, their magnitudes are same. ठीक है जी, you have seen, you got this as minus 4.15 megapascals. ठीक है जी, and this one as well you got as minus 4.15 megapascals. So it means that the magnitude of the normal stress depends on the plane, orientation of the plane. The designation of the stress may change, but the magnitude of the normal stress remains same. Is this point clear? If you have any confusion, you can ask me now. Clear? Other thing is the shear stress. You can see this now. It was minus 30. In the first case, the x-axis was oriented at minus 30. The second case, it was oriented at 60 degrees. So the combined difference is 60 minus 30. So it is 90 degrees. So initially, you got tau xy transformed shear stress as minus 68.79 megapascals, and now you got tau x dash y dash as 68.79 megapascals. ठीक है जी, so only the sign has changed, the magnitude remains the same. Only the sign has changed, the magnitude remains the same. Is this clear?
Yes, sir.
let's come to the book. Now in the book you can see they have calculated sigma x dash, tau x dash, y dash for theta minus 30 degrees. Then they have repeated the same question with theta 60 degrees. Okay, and you got sigma x dash as minus 4.15 megapascals, tau x dash y dash as 68.8 megapascals. Here, tau x dash y dash has been calculated twice in order to provide a check. The negative sign for sigma x dash indicates that this test acts in the negative x direction. Okay, and next we can show our results in this form. If you we can also show our stress in this form. For our case number 1, ठीक है जी, in our case number 1, sigma x dash was minus 25.85 megapascals, uh, tau x dash y dash was minus 68.79, so that you can show with the negative signs. In the second case, you have sigma this tau x dash y dash as positive 68.79 megapascals. ठीक है जी? So you can also show the state of the stress on the element. ठीक है जी? So that you can show just similar to this for both theta 30 degrees and theta 60 degrees. Is this thing clear? If it is clear, then next thing is, if it is clear, then let me show you one more slide. Just a moment, the slide is opening. Is this present slide visible?
Yes, sir.
Okay. Now there is few sign conventions which we need to study. That is stress transformation. First, we have already done this, so just I want to repeat it so that you can understand why we are doing this purchase sign convention. First, we need to establish the sign convention. So as we know that sigma x and they're positive and they will act in positive x and x dash direction. In case shear stress tau xy and tau x dash y dash, they will be positive. They will be positive when they will act in the positive y and y dash direction. So guys, only difference is the shear stress, what you say, sign convention of the shear stress. So shear stress tau xy and tau x dash y dash, they will be considered positive when they will act in the positive y and positive y dash direction. So this is just the new thing. Then they have explained that why we take clockwise angle theta clockwise as negative, and angle theta counterclockwise as positive. The orientation of the plane, the orientation of the plane on which the normal and the shear stress components, normal stress आपका कौन सा जी, sigma x and sigma y, and the shear stress component tau x y, ठीक है जी. So the orientation of the plane on which the normal and the shear stress components are to be determined will be defined by the angle theta, which is measured from positive x-axis to the positive x dash axis. Is this point clear? We are also doing the same, that we are measuring the angle from positive x-axis to the positive x dash axis. Is this point clear?
Yes, sir.
Okay. The positive z or z dash axis is established by the right hand rule. How the right hand rule? That if you move your fingers from this x axis towards the x dash axis, if you curl your fingers from x axis to x dash axis, then your thumb will point. ठीक है जी. If your thumb will point out of the plane, it will be considered positive. If your thumb point into the plane, it will be negative. So this is now counterclockwise. Counterclockwise. So if I turn my fingers from x to x dash axis, my thumb will point out of the plane. My thumb will point out of the plane. So counterclockwise direction is considered positive. However, if you take the clockwise direction, let's say x dash axis is downwards. So if you curl your finger from x to x dash axis, in that case your thumb will point into the plane. In that case your thumb will point into the plane. ठीक है जी. And your theta will be clockwise and clockwise will be negative. Theta will be negative. Fine. Is this clear that if I turn my fingers from x to x dash axis and if my thumb point outward, typically it will be positive and it is your counterclockwise. If it points inward into the plane, it will be negative clockwise. So, okay, ji. Now next thing we have to study that just short while ago we have done a numerical in which we were given the theta, and using that value of theta we have calculated the transformed normal stress and transformed shear stress. We have calculated the transformed normal stress and transformed shear stress. ठीक है जी. Now, the another thing is we want to calculate the maximum values of the normal stresses, maximum positive and maximum negative, and the plane over which this maximum positive and maximum negative will occur, that will be my principal plane. So I want to know that value of theta, which will give me the maximum value and the minimum value of the normal stresses. So principal stresses, they can be defined as the extreme values of the normal stresses possible in the material. Principal stresses, they are defined as the extreme values of the normal stresses possible in the material. These are the maximum normal stress and the minimum normal stress. These are the maximum normal stress and the minimum normal stress. So maximum normal stress will be called as major principal stress, while minimum normal stress will be called minor stress. So maximum normal stress is contracted minimum value of minor speed. Now principal plane is the plane through which major stress and minor principal stresses will occur. So principal plane as the plane. Principal plane may be defined as the plane on which normal stress attains its maximum and minimum value. The plane on which normal stress attains its maximum and minimum value. So principal planes, so these planes are called as major principal plane. So over the major principal plane, you will have major principal stress, and over the minor principal plane, you will have the minor principal stress. And one more thing to be noted, okay, one more thing to be noted, we will prove this, that the shear stress on the principal planes, shear stress on the principal planes is zero. ठीक है जी, ये हम प्रूव भी करेंगे that the shear stress on the principal plane is zero. So I repeat, principal planes are the planes over which the extreme values of normal stresses will occur. The maximum normal stress and the minimum normal stress. Maximum normal stress is your major principal stress and minimum normal stress is your minor principal stress. Major principal stress will occur on major principal plane and minor principal stress will occur on minor principal planes. And the shear stress on the principal planes is always zero. The shear stress on the principal planes is zero. Then comes the principal axis. Now, principal axis, they are different from the principal planes. Principal axis, they are different from the principal planes. Principal axis may be defined as the axis over which moment of inertia will be maximum or minimum. ठीक है जी, the principal axis is, on the major principal axis you will get the maximum moment of inertia, and on the minor principal axis you will get the minimum moment of inertia. However, product moment of inertia over the principal axis, product moment of inertia over the principal axis will be zero. So Ixy will be zero over the principal axis. Now other point which is important to understand here, that the principal plane is the property of the stress. The principal plane is the property of the stress, whereas principal axis is the property of the moment of inertia. ठीक है जी, principal axis is the property of moment of inertia. In general, there is no relationship between principal axis and principal plane. Is this point clear? Another point to be which we have already studied, that the normal stresses, they are represented by a single subscript like sigma x, sigma y, sigma z. However, shear stresses, they are represented by double subscript like tau xy, tau xz, tau yx, tau yz. ठीक है जी? So shear stresses, they are represented by double subscript, whereas your what you say, your normal stresses, they are represented by single subscript. Gee guys, any question about today's lecture? Okay. Guys, today we could not start at 11 o'clock. The reason is I am promoted to associate professor level, so I have to, what you say, give the joining, and it took us about 2 hours. So, like I was busy from 10 to 12, so that's why I could not start the lecture at 11. So tomorrow we have lectures 11 to 12. So what I will do, I will start the lecture at 10 because tomorrow we have to do this orientation of the principal planes, orientation of the shearing planes. Then we have to calculate the major principal stresses and minor principal stresses, maximum shear stresses. So all this we have to do tomorrow along with the numericals. So guys, tomorrow we will have a lecture at 10 to 12. Please note it down. Is this clear, guys?